Right, now I'm going to talk about arrows. I've got a few to show you. First one is your classic, arrow-shaped arrow. It's like a pointy arrowhead, just like, you think of an arrow, don't you? You think of it looking like this. Well, this is actually, certainly in the late medieval period, not a war arrow. This is a hunting arrow. It has big barbs on it for sticking in the prey, and it has big cutting surfaces for cutting its way into a deer or something like that and causing it to bleed a lot. And then you can set the hounds on it. Lots of fun. One of the ways that you can tell this is a hunting arrow and not a war arrow is by looking at the thickness of the shaft. You see, this is a war arrow. Look at the difference in the thickness of the shafts there. I don't know how clearly you can see that actually. I'm going to get it even closer. You see one is considerably thicker than the other. And another thing you'll notice, I'm going to put the bow down, is that the war arrow is longer, and the war arrow has much longer fletchings on it. This has got about 7 inches of fletching. This has got about 4.5, something like that. And the reason is the war arrow is so much more massive that it needs longer fletchings to keep it stable in flight. Now, another difference is that with war arrows, you very seldom see anything on the arrow, very seldom see anything that any little sort of peg, any little hole there, holding the arrowhead on. Instead, the arrowhead is just a socket put on the end of the shaft. And quite often that was done just with beeswax, not even proper glue. The idea being that with a war arrow, you don't want anyone to be able to shoot it back at you. So you twang it with its beeswax holding it on, and it lands in a tree or a Frenchman or the ground or something, and then any enemy pulling the arrow out to shoot it back will probably just get a wooden shaft because the head will stick in the tree or the ground or the Frenchman or whatever it was. So that was one way you could foil your enemy by just using beeswax. Now I'm told that if a beeswax headed arrow went into you, it was very difficult to get the arrowhead out of you because body temperature would melt the beeswax, and then when they tried to extract the arrowhead would be left in you, and of course that's a focus for infection and that could kill you in the long term, and that's very nasty. Yes, I suppose that's possible. I do wonder though, what happened on just a very hot day? Surely on a very hot day all your arrowheads would have fallen off, so I think there's something more to that. This type of arrowhead, by the way, is called a Type 16. Yep, that's the best name that anyone managed to come up with for this kind of arrowhead. It's a sort of multi-purpose late medieval warhead. And though it does have barbs, the barbs come back. They're so close to the shaft, the barbs. Hang on, I have to put my hand there so it focuses. They're so close to the shaft that they don't actually catch on much. This is a sharp arrowhead. So it's almost a vestigial barb, really. So it's a big, slightly pyramidal point for sticking in Frenchman. The other end, you'll notice that there's some horn that's been let into the nock there. That's to stop the very high poundage bow splitting the arrow lengthways. And one of the reasons you have such a massive arrow is to stop the entire arrow shattering, because a huge amount of energy is put in at this end of the arrow. Now the arrow itself, having mass, also has inertia, so it doesn't want to go anywhere. And the bit that's densest, so has the greatest inertia, is this bit right on the end. So the bit that wants to move the least is at the front, and there's all this reluctant mass behind it. And with the energy being pushed in this way, the result is the whole arrow will bend. Now, if you've got a 120-pound bow and you put one of these in it, it will bend so much it will just shatter. It'll shiver into 1,000 bits, and you will send just a load of firewood a few yards in front of you. Not much use. So for the war bow, you need a more massive arrow. But there's another reason too, because when eventually it slams into a Frenchman, you want the mass of all that wood behind it pushing in to the Frenchman. But of course, why do you need such a massively powerful bow? Because the Frenchman, the crafty little beggar, was wearing loads of armour. Now, here are the 3 principal types of head for dealing with Frenchmen in armour. Now, if he's wearing plate, I'm going to have to put my hand there so it's got something to focus on. There you go. If he's wearing plate, you want one of these massive squarish points, you see, and that has got a very fat collar on it. So the idea with this is it hits, it's very big, massive and hard. I can tell you, it's really quite a weight I can feel on the end of the arrow. The balance point is very, very close to the front of the arrow. And that will punch through and it'll cut into the armour, and like a can opener, it'll bend the armour in 4 different directions, and the collar is big enough so that the entire arrow can follow it through the armour into the Frenchman. Contrast it with this, where you have a long, thin, narrow spike on the end, a bodkin point, and this is useful if he's wearing mail, because this will go through the rings of the mail, possibly through some padding, and wound him even though the whole arrow doesn't necessarily follow through. And this was the commonest, the Type 16, and it's a sort of compromise all-round twanging head. Fill the air full of these and that should do the job. So, I've been watching some very slow motion footage of arrows being shot out of bows, and one thing that's very clear is that the arrows do bend a lot when they're leaving the bow. And I'm fairly sure, not completely certain, but I'm fairly sure that when they leave the string, they are still bent. That's significant, because if they were still in contact with the string when they straightened out, they would be able to push off the string and actually use this force of straightening, all this energy stored in the bent arrow, to spring off the string, and that would add a bit of power to the shot. But as far as I can tell, it's not easy to see even at very slow motion. As far as I can tell, they leave the string still bent and then straighten out in mid-air. And they straighten one way, other way, on way, other way. And so I think that is an inefficiency. I think that's a lot of wasted energy there. So with a stiffer arrow, you would waste less energy. I don't think there's any way you can alter things so that it will spring off the arrow, because it would have to go so slowly that that wouldn't really work. I've read some reports on the use of quilted gambesons and the like, multi-layers of linen and canvas and padding, and according to them, and I can believe this, it's actually arrowheads like this with a lot of cutting edge that do better at cutting through layers of cloth. When I was making a padded coif recently, I found that I actually bent needles trying to push through it. I was surprised, but it does happen. It's very difficult to push a needle through a load of quilted padding. So possibly these are actually less good against padded armour, which may explain why so much chainmail and padded armour was worn in combination. One reads of pincushion-like crusaders who had been shot many times but were able to keep going. Right, I probably think of other things I could have said about arrows in a moment, but I'm going to leave it there.